Building a drone that flies is easy, but building a drone that can see a target, lock onto it, and precision drop a payload, that is a different beast. Today, I'm showing you a ROS 2 project where I turn a standard PX4 drone into an autonomous bomber. We are going to look at the computer vision code that tracks these red markers and the custom spawner mechanism that drops the packages. Let's get into it. First, let's look at the mission field. I'm running this in the Gazebo simulator. I manually set up a drop course by placing 3 red landing pads on the grass. The challenge is simple. The drone has to find these specific red squares. It can't just be near them, it has to be perfectly centered to trigger the mechanism. Now, let's look at the code. I wrote a ROS 2 node called Visual Navigator. Its first job is to see. Here, I'm using Python with RCLPY, and the first thing I needed to solve was what acts as the payload. Instead of loading an external 3D model file, I defined the payload directly in the code using this XML string called payload SDF. I gave it a mass of 0.2 kilograms and a blue color. This is critical because we define the mass and inertia here. Gazebo's physics engine will treat it like a real object with weight. It falls, it bounces, and it interacts with gravity. In the init function, I set up the rules of engagement. I didn't want the drone to drop the box in the millisecond it saw the red. That's too twitchy. So I added these logic variables. Required hover duration, I set this to 2 seconds. The drone must hold position before releasing, and then drop cooldown I set to 10 seconds. This prevents the drones from spamming drops and give me time to fly to the next marker. Now for the main loop, the image callback. This runs every time the camera sends a new frame. First, I convert the image from BGR to HSV color space. I define a low and upper range for the color red. This creates a mask where the red markers are white and the grass is black. I use CV to find contours to find the shape. If the area is big enough, I calculate the center point CX, CY. Here is the decision logic. I check if the target center is within 40 pixels of the camera center. If we are aligned, I start a timer. If the timer hits 0, we call self-spawn payload. But if I drift off target, self-hover start time resets to none. You have to be perfect. Finally, the spawn payload function. This is where the magic happens. ROS 2 doesn't have a drop command, so I'm using the spawn entity service. Every time this runs, I increment the payload count, so every box has a unique name. Box 1, box 2, etc. Look at this line. Position Z equals to -0.2. I am telling the simulator to spawn the box 20 cm below the drone. And crucially, I set the reference frame to Iris, which is my drone. Wherever the drone is in the world, the box appears right underneath it. Gravity takes over immediately, and to the viewer, it looks like a mechanical drop. Now, let's put it all together. I'll show you the full workflow from a fresh start. I begin by launching the standard PX4 simulation. For this mission, I want a custom course, so I'm building it manually right here in Gazebo. I drop a simple cube, enter the model editor, and flatten it into a landing pad. I apply a Gazebo red material so our computer vision system can see it. Once the first one is perfect, I just copy and paste it to create 3 distinct drop zones. And just like that, the mission field is ready. With the world set, we need to launch the software stack. First, I start my ROS2 node. This initializes the camera subscriber and the spawner service. It's now sitting and waiting for the image. Next, I open Q ground control to monitor and to control my drone. And finally, to start the mission, I typed Commander takeoff directly into the PX4 console. The drone arms, spins up, and holds a hover at 2 meters. We are airborne. I'm flying manually towards the first sector. Watch the terminal on the left side of the screen. I'm aligning with the red marker, hold in position, and there. The system detects the lock, triggers the spawner, and you can see the lock dropping payload number 1. Moving to target 2, the system is in cooldown, so I have time to reposition. I'm lining up the crosshair and drop. Payload number 2 is confirmed in the logs. Final approach. The beauty of this system is that the code handles the precision. I just have to get it close enough. Target acquired. Boom. Payload number 3 is deployed. Mission successful. All packages delivered. So that is how you combine ROS2, OpenCV and Gazebo to build a mission critical drone system. It is a great way to learn about coordinate frames and state machines. If you want to see me make this fully autonomous so it flies itself, let me know in the comments. Thanks for watching and happy coding.